Today we will be discussing Chapter 3, Section 1, which is found on page 59 of your book. It is titled The Geosphere. When you finish this section, you should be able to describe the composition and structure of the Earth, describe the Earth's tectonic plates, explain the main cause of earthquakes and their effects, identify the relationship between volcanic eruptions and climate change, and describe how wind and water alter the Earth's surface. I want you to think about the skeletal system, respiratory system, and circulatory system. How do they relate to the human body? The skeletal system supports and protects the organs such as the lungs and heart, while the respiratory system allows oxygen to enter the body and carbon dioxide to leave, and the circulatory system delivers the oxygen to the various parts of the body and carries the carbon dioxide back to the lungs. Now, I want you to think about the geosphere and how it relates to the Earth. In your science journal, I want you to write the prompt and your answer. The Earth is an integrated system that consists of rock, air, water, and living things. They all interact with each other. Science has divided this system into 4 parts: the geosphere, which are the rocks, the atmosphere, which is air, the hydrosphere, which is water, and the biosphere, which is living things. The geosphere is mostly solid, rocky part of the Earth that extends from the center of the core to the surface of the crust. The atmosphere is the mixture of gases that make up the air we breathe. Nearly all of these gases are found in the first 30 kilometers above the Earth's surface. The hydrosphere makes up all the water on or near Earth's surface. Much of this water is in oceans, which covers nearly 3/4 of the globe. However, water is also found in the atmosphere, on land, and in the soil. The biosphere is the part of the Earth where life exists. It is a thin layer at Earth's surface that extends from about 9 kilometers above Earth's surface down to the bottom of the ocean. The biosphere is therefore made up of parts of the geosphere, the atmosphere, and the hydrosphere. Today we are focusing on the geosphere. Scientists use seismic waves to learn about the Earth's interior. Seismic waves are the same waves that travel through the Earth's interior during an earthquake. A similar process would be you tapping on a melon to see if it is ripe. A seismic wave is altered by the nature of the material through which it travels. Seismologists measure changes in the speed and direction of the seismic waves that penetrate the interior of the planet. With this technique, seismologists have learned that Earth is made up of different layers and have inferred that substances make up each layer. Scientists divide Earth into three layers: the crust, the mantle, and the core. The layers tend to become progressively denser towards the center of the Earth. The crust is a thin and solid outermost layer of the Earth above the mantle. It is the thinnest layer and makes up less than 1% of the planet's mass. It is 5 kilometers to 8 kilometers thick beneath the ocean, and it is 20 kilometers to 70 kilometers thick beneath the continents. Why do you think it's thinner beneath the oceans? Think about it. Have you ever tried to carry a 10-gallon bucket full of water? Now, just imagine there are about 332.5 million cubic miles of water on the planet, and each cubic mile contains more than 1.1 trillion gallons of water. I believe that would tend to press down on the molten materials such as rock and make it more compact and dense. The mantle is the layer of rock between the Earth's crust and core. The mantle is made of rocks of medium density and makes up 64% of the Earth's mass. The core is the central part of the Earth below the mantle, and it is composed of the densest elements. The Earth can be divided into 5 layers based on the physical properties of each layer. The lithosphere is the solid outer layer of the Earth that consists of the crust and the rigid upper part of the mantle. It is a cool, rigid layer that is about 15 kilometers to 300 kilometers thick and is divided into huge pieces called tectonic plates. The asthenosphere is the solid, pliable layer of the mantle beneath the lithosphere. It is made of mantle rock and flows slowly, which allows the tectonic plates to move on top of it. Beneath the asthenosphere is the mesosphere, the lower part of the mantle. Earth's outer core is a dense liquid layer. At the center of the Earth is a dense solid inner core, which is made up of mostly iron and nickel. Although the temperature of the inner core is estimated to be between 4,000 degrees Celsius to 5,400 degrees Celsius, it is solid because it is under enormous pressure. The inner and outer core make up about 1/3 of the Earth's mass. Tectonic plates are blocks of lithosphere that consist of crust and the rigid outermost part of the mantle, and they glide across the underlying asthenosphere. The continents are located on tectonic plates and move around with them. The major tectonic plates include the Pacific, North American, South American, African, Eurasian, Australian, and Antarctic plates. Most of the geological activity on the surface of the Earth takes place at the boundaries between tectonic plates. Tectonic plates may separate, collide, or slip past one another. Enormous forces are generated with these actions, causing mountains to form, earthquakes to shake the crust, and volcanoes to erupt along the plate boundaries. Tectonic plates are continually moving around Earth's surface. When tectonic plates collide, slip by one another, or pull apart, enormous forces cause rocks to break and buckle. Where plates collide, the crust becomes thicker and eventually forms mountain ranges, such as the Himalaya Mountains. A fault is a break in the Earth's crust along which blocks of the crust slide relative to each other. When rocks that are under stress suddenly break along a fault, a series of ground vibrations known as earthquakes is set off. Earthquakes are occurring all the time. Many are so small we cannot feel them, but some are enormous movements of the Earth's crust and cause widespread damage. The measure of the energy released by an earthquake is called the magnitude. The smallest magnitude that can be felt is 2.0, and the largest magnitude ever recorded is 9.5. Magnitudes greater than 7 cause widespread damage. Each increase of magnitude by one whole number indicates the release of 30 times more energy than the whole number below it. The map shows us the majority of earthquakes take place at or near tectonic plate boundaries because of the enormous stresses that are generated when tectonic plates separate, collide, or slip past each other. Over the past 15 to 20 million years, large numbers of earthquakes have occurred along the San Andreas Fault in California, where parts of the North American plate and the Pacific plate are slipping past one another. This slide shows you where recorded earthquakes have occurred. Scientists cannot predict when earthquakes will take place. However, they can help provide information about where earthquakes are likely to occur, helping people prepare. An area's earthquake hazard level is determined by past and present seismic activity. Earthquake-resistant buildings are being built in high-risk areas. As you can see, they have reinforced walls and are slightly flexible at the base of the building so they can sway with the ground motion, preventing them from collapsing. A volcano is a mountain built from magma or melted rock that rises from the Earth's interior to the surface and can occur on land or in the sea. Volcanoes are often located near tectonic plate boundaries where plates are either colliding or separating from one another. The majority of the world's active volcanoes are located along tectonic plate boundaries that surround the Pacific Ocean. This area is known as the Ring of Fire. Volcanic eruptions can affect local communities by emitting clouds of hot ash, dust, and gases which can flow down the slope of the volcano at speeds of up to 160 kilometers per hour and sear everything in their path. During an eruption, the ash can mix with water and produce a mud flow that runs downhill. In addition, ash that falls on the ground can cause buildings to collapse under its weight, bury crops, damage the engines of vehicles, and cause breathing difficulties. Major volcanic eruptions can have a global effect. Eruptions can change the Earth's climate for several years. In large eruptions, clouds of volcanic ash and sulfur-rich gases may reach the upper atmosphere and spread across the planet, reducing the amount of sunlight that reaches the Earth's surface. The reduction in sunlight can cause a drop in the average global surface temperature. The Earth's surface is continually battered by wind and scoured by the running water, which moves rocks around and changes their appearance. These processes are called weathering and erosion. Weathering is the process in which the material of the Earth's surface are loosened, dissolved, or worn away. Weathering wears down rocks and makes them smooth as time passes on. Older mountains are therefore smoother than younger ones. Erosion carries the material away. Erosion transports the materials from one place to another by a natural agent such as the wind, water, ice, or gravity. Erosion by both rivers and oceans can produce dramatic changes on the Earth's surface. Waves from ocean storms can erode coastlines to give rise to a variety of landforms, as shown in the picture on the left. Over time, rivers can carve deep gorges into the landscape, as shown in the picture to the right. Wind erosion can also change the landscape of the planet. In places where few plants grow, such as beaches and deserts, wind can blow soil away very quickly. Soft rocks, such as sandstone, erode more easily than hard rocks, such as granite.